Let's talk about this data set, hospital admission. So here we have some numbers, of course not the real numbers, where you have age of the patient, health status, higher the better, vaccine status, yes or no, and hospitalization. So these are the past records. So for instance, this person was 75-year-old and not a very good health condition, didn't take the vaccine, was admitted in the hospital, whereas 77-year-old person in good health condition did take the vaccine, didn't go to hospital when he or she felt sick. So that's what it is. Now from here, we are going to basically create a logistic regression model. We're going to answer questions for the future people. This is a history already. So what are the questions we may ask? If somebody is 60-year-old, didn't take vaccine, in good health, what are the chances he or she will be admitted if he catches the virus? What are the odds of a non-vaccinated person needing hospitalization? The R program is at the end. We're going to read the Excel file, run the regression program, get the regression coefficient, and compute the probabilities and odds. So here, for instance, when we run the program, we get this output, this regression output: intercept, slope 1, slope 2, slope 3 for age, health, and vaccine. So this is our output for the log odds. Now we can compute these ones here. So the log odds we had, now we're going to go a person who is 50-year-old, health condition 5, vaccine yes. So we have put 50 here, 5 here, and 1 here, as we show here. Now log odds become now 0.249710. Just simple calculations, you can do it. Check it out. That gives us odds equal to e to the power that number, right? We have used base e for log conversion, so now I want e to the power that. In Excel, it will exp function. In R also exp function. So from here we can calculate probability is 0.07606. So a person who is 50-year-old, health condition 5 out of 10, took a vaccine, has only about 8% chance of being admitted. Okay, so someone did not take the vaccine. Same thing, 50, 5, and didn't take the vaccine. Once again, this becomes 0 now. When we do the same calculations, we get probability equal to 0.3673. So this is higher probability than the other person. It's still below 50%, regardless it's high. So now we have this question of odds. Somebody does not take a vaccine and takes a vaccine. How will that work out? So 55 no vaccine, 55 yes vaccine. Remember, these are the same things. We're only checking this portion here. Probabilities and this one, odds here. So now what are the odds? That simply will be this over that. I mean this over that. This over that 7 times. So in conclusion, if you do not take vaccine, chances of you going to hospital if you fall sick is 7 times more than the person who takes vaccine. 70 and 6, no, yes, this changed. Now 70-year-old has higher probability of getting admission than this person who took the vaccine. But what are the odds? Same odds exactly. So the point is that they become constant, only this one. So that way we can figure out the impact of vaccine itself. It doesn't matter. Yes, chance of both going in the hospitals are higher comparing to a 50-year-old. But within them, it's about 7 times more likelihood you'll go to hospital if you didn't take a vaccine than you took the vaccine. That's what we're trying to achieve here. So odds didn't change. So here we have a 50, 5, and 1. 1 means took the vaccine and age group. So these are the same thing. We keep the constant. So we can check the impact of age. So for instance, 50 to 51, the odds are 1.05, slightly more than if you are 50-year-old. How about 50 to 54? This person has 1.21 or 1.22 times more chance of hospitalization than this person. How about 75-year-old? almost 3.5 times more than this person, which makes sense, younger and old. But interesting thing is this. Age difference is 1, 4, 7, 50, 15, etc. Now look at this. For 1, it is 1.0502. How about for 4 years? Simply raise to the power 4, you get that number. 7, that number. 15, that number. So really, once you have one of these ones figured out, you can figure out any age difference. If age difference is 6 years old, what will that be? This to the power 6. And once again, I seriously suggest that you make this calculation on your own. You have everything there, do on your own to feel comfortable. Here's the R program, the basic code. So we basically run the regression model, generalized linear model, families binomial, hospital is our output basically, and age, health, and vaccine are our dependent variables. This gives you efficient output of the regression output. Now we can simply get variable 1 is the intercept, 2 is slope 1, slope 2, slope 3, etc. Then we can compute, just call logit A, that simply will be the intercept plus 50 times, that's the age, times the slope for that one, 5 times, this is the health condition, slope for that one, and 1 times this one, this is the vaccine status, yes, 1 times the slope for that one there. That gives you odds, log odds. You can do odds using exponential there, exp function, this is the e to the power, and probability now becomes odds over 1 plus odds. So this kind of a key of the regression code. Here's the full code that you can use. Of course, you have to make changes. There's a set directory. This clears the memory. You set the directory. You open the library to read Excel file. You read the Excel file. Sheet is vaccine, whatever your sheet number is. And this is you assign this variable to this file. And then you run the regression. Now remember, what is hospital? Hospital coming from this file. So we put FFF dollar. Age, this one. If you do not do this one, you can do attach, FF, attach. When you do attach, it's not a good idea. Then you don't have to remove, you don't have to put these ones in there. Your output, then we assign the variables, C1, C2, C3, C4, and we can simply do calculations just like you've done here. So that's your regression output. And this pretty much concludes our discussion on part 2 of logistic regression.